So the rectangle and square below have the same area. The dimensions of both are in centimeters. The diagrams are drawn not to scale. Not drawn to scale. Find the area of the rectangle. Okay. So the area of the rectangle is length multiplied by width, which is 6 minus root 11 multiplied by 6 plus root 11. Now what we can do here is 6 by 6 is 36, 6 by root 11 is 6 root 11, root 11 by minus 6 is minus 6 root 11, and finally minus root 11 by minus root 11 is minus 11. These two cancel and what we get is 25. Now remember, if that failed you, you can always use the calculator. You always go 6 minus root 11 multiply by 6 plus root 11. Find the length of the square. Okay, so this is 25 centimeters squared. The dimensions of both are they have the same area. So this means this is 25 centimeters squared. Now remember, a square has the same length and width. So length multiplied by width is x multiplied by x, which is x squared. X squared must be equal to 25. X therefore is equal to 5. So the length of the side of the square is 5 centimeters. Okay. Now we're on question 7. Given any two positive integers m and n, where n is bigger than m, it is possible to form three numbers a, b and c, where a equals n squared minus m squared, b equals 2nm, and c equals n squared plus m squared. These three numbers a, b and c are known as Pythagorean triple. For m equals 3, n equals 5, calculate a, b and c. Okay, so this is very much just an input question. You can use pretty much the calculator for most of this one. Okay, we'll see what happens. So first one, a is equal to n squared minus m squared, so it's going to be 5 squared minus 3 squared. A equals 25 minus 9. A equals 16. The next one, b equals 2 multiplied by n, which is 5 multiplied by 3. Put that into the calculator, you get 30. B equals 30. And c equals n squared plus m squared, which is going to be 5 squared plus 3 squared. And what we get here is 25 plus 9, which is 34. Okay, so that's done. Find the value of a, b and c from part 1 if the lengths of the sides of a triangle show that the triangle is right angled. Okay, so if it's a right angled triangle, the side that's opposite the right angle must be the largest side, and the largest side is 34. So 34, and the other two sides is opposite the 90-degree angle. Okay, and the next part is show that the triangle is right angled. So the smaller part is 16 and the other one is 30. Now if it's a right angled triangle, Pythagoras' theorem works, as in the longest side squared, the hypotenuse squared equals the sum of the other two sides squared. So side 1 squared plus side 2 squared. So what's going to happen here is we're going to get 34 squared equals 30 squared plus 16 squared. So we're going to figure out what these are in the calculator. 34 squared, 1156. Then we're going to have 900 plus 256. Add them together, 1156 equals 1156. Because it balances, it obeys Pythagoras' theorem, therefore the triangle is right angled. Now, if n minus m squared, 2nm, and m squared plus m squared are the lengths of the sides of the triangle, show that the triangle is right angled. So once again, we have a right angled triangle, and what we're looking to do is we're looking to prove that it works for any value of n and m. Now remember, the biggest side was c, which is n squared plus m squared. from, we got 34 for it last time, so n squared plus m squared, and then let that be the hypotenuse or the longest side. Let 2nm be the other side, and m squared minus m squared the other side. So if this works for Pythagoras' theorem, so the hypotenuse squared equals side 1 squared plus side 2 squared, it only works, it's a right angle triangle if it balances. So what we're going to get is n squared plus m squared squared equals side 1 squared, which is going to be 2nm squared, plus side 2 squared, which is n squared minus m squared to be squared. Now let's see what this is. It's going to be n squared plus m squared times n squared plus m squared. This one's going to be 4 n squared m squared, because it's 2nm multiplied by 2nm, which is 4 n squared m squared, and then we're going to have n squared minus m squared, n squared minus m squared. Okay, let's multiply out. We get n4, we get n squared m squared, we also get n squared m squared, and we get plus m4 equals 4n squared m squared. And what we're going to get here is n4 minus n squared m squared minus n squared m squared and plus m4. Let's see what happens both sides. The m4's cancel both sides. The n4's cancel both sides. This adds together to become, the two of these together will become 2n squared m squared, and this here will be 4n squared m squared minus, and the two of these will be minus 2n squared m squared, and finally we're going to get 2n squared m squared equals 2n squared m squared. So basically Pythagoras' theorem works. Pythagoras' theorem works. The sides do represent a right angle triangle. Do represent a right angle triangle. Okay. Next one. The question picture below shows the top section of Spanish Arch in Galway City. George wants to see if the arch can be described by a function. He puts the coordinate grid over the arch as shown. Complete the diagram shown. Okay, so that's going to be, if we were to draw a blue picture of a blue arc, okay, over this. So what we're going to get is the first one is minus 3, and it's going to be 1.5. Minus 2, and it should be around 3. Minus 1 is 3.5. It's going to be 0 around 3.7. 1 is going to be around 3.5. 2 is around 3. And finally 3 is around, 3 is also around 1.5. Okay. Now, is it possible to represent this section of Spanish Arch by quadratic function? Give a reason for your answer. Yes, because it is an n-shaped curve. That is symmetrical or the same. Around the y-axis. So basically, if you go to the top and you can see the y-axis is here, you can see that it basically, when you draw a line through the y-axis, it cuts the blue curve in half, and that's why we know it's symmetrical, because it's the same in both directions. Okay, so this is symmetry here. Okay, the same distance in both directions. Okay, next question, number 9. Bill and Jenny are two athletes running in the same direction. So they're running in the same direction at steady speeds on a racetrack. Tina is standing behind the track, and at a particular time Bill has gone 4 meters beyond Tina, so 4 meters ahead of Tina, and his speed is 2 meters per second. At the same, he's gone 7 meters beyond Tina, and his speed is 2 meters per second. At the same instant, Jenny has gone 2 meters beyond Tina, and her speed is 3 meters per second. So what we can do here is we can draw where Tina is. Tina is located here. This is Tina. Okay? 7 meters down the road is Bill. And Bill is going 2 meters per second. That's his speed. Okay? 7 meters down the road. And 2 meters down the road is is Jenny. And Jenny is going 3 meters per second. Okay? So what we're going to do next is complete the table to show the distance between the two runners and Tina over the next 10 seconds. Well, we can see that every second Bill increases his distance by 2. So he's going to be 11, 13, 15, 17, 19, 21, 23, 25, 27. And Jenny is going to be, her distance is going to go up 3 meters each second. It's going to be 5, 8, 11, 14, 17, 20, 23, 26, 29, 32. Okay? On the grid below, draw graphs for the distance between Bill and Tina and the distance between Jenny and Tina over 10 seconds. Well, I'll do Bill and Tina first in blue. Now the trick is to do the first point, which is 0.7, and the last point, which is 10.27, and that will enable you to do it quicker. So 0.7, 10.27. And this is for Bill. 0.7. Now we can see that 0.7 isn't a great point to have, because this is 6 and it doesn't fit exactly onto the graph, so we might choose a different point. Okay, so although all of them are odd, so we'll actually just have to settle with it after all, because all of the points are odd. Okay, in Bill's one, so we'll go halfway between 6 and 8, and that will get us 0.7, which is located here. And then finally the last one's 10.27, so we're going to go half. This is 26, so halfway between 26 and 28 gives us 27. Okay, so 27 is located there. Okay, so we're going to join the graph together, and this is representative of Bill. So here is Bill's graph here. Okay, so just make sure it's really accurate. Okay, you can't afford to give away any mistakes here. Okay, so that's Bill's one there. Now we're going to do Jenny's. Okay, and we'll do Jenny in red. Okay, and Jenny is going to have her first point is 0.2, and her last point is 10.32. So 10.32 is located here, and 0.2 is located down here. Now we're going to join them together via a line as well. And there we go. Now, what we can see is that they're both the same at 17 seconds. Okay, which is what we came to expect, is that they're the same at 17 seconds. Okay. So on the grid below, draw two graphs between Bill and Tina and the distance between Jenny and Tina over 10 seconds. Okay, that's done. Okay, after how many seconds will both runners be the same distance from Tina? Well, they're the same distance from Tina after 5 seconds because they're about at 17. We can see it from the graph here, down here to 5 seconds. Okay, so the answer to that one is going to be 5 seconds. Next one. After 9 seconds, which runner is the furthest away from Tina, and what is the distance between the runners? Okay, after 9 seconds. Okay, so after 9 seconds, Bill is 25 meters away, and Tina is 29 meters away. Or so not Tina, Jenny. Bill is 25 and Jenny is 29. Furthest from Tina is Jenny, and the distance between the runners is going to be 29 minus 25, which is 4 meters. Okay. Write down the formulas to represent the distance between Bill and Tina for any given time. State clearly the meaning of any letters used in the formula. Okay. Now, Bill, we call it Bill's distance, okay? So we'll call it a small d. Okay? Or dB. So dB equals distance of Bill away from Tina. Okay? Now, it's 2 meters at the start. So before time begins, 7 meters at the start for Bill. Okay? So it's 7 meters at the start, plus 2, so it's 7 meters at the start plus 2, because he moves 2 meters per second, 2 multiplied by seconds, time in seconds. Okay, and what we can do with this is we can say that time in seconds is 2t, so it's going to be 7 plus 2t. Okay, and t is time in seconds. Okay, next one, dj. Okay, so dj is distance of Jenny from Tina. Distance of Jenny from Tina. Okay, and in Jenny's case, she has 2 meters at the beginning, and every second that passes she gets 3 meters further away. Okay, so that means it's going to be 2 plus 3 times, it's going to be 2 plus 3t. Write down a formula to represent the distance between Jenny and Tina for any given time. Okay, so this is for Bill, and this answer here is for Jenny. Okay, so Bill goes here, Jenny goes here. Use your formula for 5 and 6 to verify the answer that you gave in part 3. Well, in part 3 I said after how many seconds will both runners be the same distance from Tina is 5 seconds. Okay, so what we want to do is verify that distance of Bill away from Tina equals distance of Jenny away from Tina. So we basically want to say that dB equals dj. And then what we're going to get is 7 plus 2t equals 2 plus 3t. And what we're going to get is move the t's over one side. So we're going to get 7 minus 2 equals 3t minus 2t. 5 equals t. After 1 minute, Jenny stops suddenly. From the time she stops, how long will it until Bill is level again with her? Okay, so the rule is the distance Jenny has covered equals 2 meters plus 3 multiplied by time in seconds. Time for this question is a minute. T equals 60. Okay, So the distance of Jenny away from Tina is going to be 2 plus 3 multiplied by 60, which is 182 meters. Okay, so she's 182 meters away from Jenny. Okay. Now we have to find the distance of Bill away from Tina at this time as well. Okay, so the distance of Bill away from Tina is going to be 7 plus 2t, which is going to be 7 plus 2 times 60, and that equals 127 meters. Now at this point in time, it's 182 minus 127, which is the gap between both of them is 182 minus 127 is 55 meters. Okay, so Jenny is 55 meters ahead of Bill. Okay, so Jenny is 55 meters ahead of Bill. Now every second, remember, time equals distance over speed. Now that Jenny has stopped, time equals distance over speed, and what we can say is that the distance between both of them is 55 meters, and Bill is covering 2 meters per second. This means that it's going to be 55 divided by 2, which is going to be 27.5 seconds. So time is going to be 27.5 seconds after Jenny stops. Okay, so it's after Jenny stops. From time she stops, so it's going to be 27.5. If Jenny had not stopped, how long in total would it be until the runners are 100 meters apart? Okay, so if she didn't stop. Okay. Well, if she didn't stop, okay, there's a way we can do this. 2 different ways, okay? The first way is realizing that after 60 seconds, they're 55 meters apart. So when t is 60, their distance between Bill and Jenny is 55 meters. Now, what's happening every second is Jenny is running 3 meters per second, while Bill is only running 2 meters per second. So this means that every second that passes, Jenny is making up a meter every second. So basically 55 meters is 45 meters short of 100. So we need another 45 meters, okay? So we're going 100 minus 55 is 45 meters. Okay, we need 45 meters more between them, and if we divide that by 1 meter per second, which is how much faster Jenny is than Bill, what we get here is we will get 45 seconds. Now, there's another way of doing it, and the other way of doing it is the following. Okay, so it's 45 seconds longer, and that plus the original 60 will mean t is equal to 105 seconds in total since they passed out Tina. Okay, how long in total means 105 seconds. Okay, now let's think of it from another way. Let's think of it as a distance. The difference between their distances is going to be d Jenny minus d Bill. Okay, the distance Jenny is away from Tina minus the difference Bill is away from Tina is the difference difference in distance between Jenny and Bill. Now we can write down both formulas. Okay, so what we can do is we can write down Jenny is going to be 2 plus 3t, Bill is going to be 7 plus 2t, and the difference we want is 100 meters. Okay, so what we do next is we plug this in, and what we're going to get is 2 plus 3t, basically minus 1 there, minus 7 minus 7t equals 101, or equals 100. Oh, sorry, excuse me, it's not 7t, it's 2t. Okay, so 3t minus 2t is t, t minus 2 minus 7 is 5, t minus 5 equals 100. Okay, and now we bring 5 over the other side, and t therefore is equal to 105 seconds. So that's another way of doing it. Since the time clock first start, it's 105 seconds for them to be 100 meters apart. Okay, number 10. Okay, right, in terms of x, the area of each section into Kevin's diagram below. Okay, now remember, a plot consists of a rectangular garden measuring 8 by 10, which is 80 meters squared, and the total plot of the area is 143 meters squared. So what happens here is this part here is 80. Now it says the width of the path, so this is going to be x times x, which is x squared. That's going to be x squared as well, x squared and x squared. The reason being is that the width of the path is x on both sides, and we know that area equals length multiplied by width, and length multiplied by width, if they're both x, must be x squared. Now the next part is going to be basically 10 multiplied by x is going to be 10x. This side here is also going to be 10x, because this one here has a length of 10 and a width of x, so that gives us 10x for both of them. And then finally the last one is going to be a width of 8 and a length of 8 and a width of x, which gives us 8x. Now we got to add up all the areas together. So what happens is when we add all these up together, we get 143. So we're going to get x squared plus x squared plus x squared. We have 4x squared, okay, because if we count them, okay, we got 1, 2, 3, 4. 4x squared. And then we have 10x plus 8x plus 8x plus 10x. And what that's going to give us is 36x. And then finally we're going to have our 80 in the middle. And all this equals the grand total of 143. Bring the 143 over the other side, and we're going to get 4x squared plus 36x minus 63 equals 0. Okay. Next one is going to be Elaine writes down the length and width of the plot in terms of x. She multiplies these and sets the answer equal to the total area of the plot. So what we're going to get here is from this side to this side, it's going to be 8 from here to here, and x, so that's going to be 2x plus 8. Then on the bottom it's x from here to here, 10 from here to here, and then another x from here to here, and that's going to be 2x plus 10. Okay, write down in terms of x the length and width of the plot on Elaine's diagram. Done. Okay. Next thing, write down a simplified equation which you think Elaine got. So what Elaine will get is this. She's going to get length multiplied by width, and length multiplied by width equals 163. We're going to multiply it out. We're going to get 4x squared plus 20x plus 16x plus 80. And then bring that over and we get minus 163 equals 0. No, sorry, it's plus 80, not 180, just 80, okay? So that's plus 80 there. Okay? Oh, and sorry, it's not 163, it's 143. Excuse me, that's not 163, it's 143. Just make sure to reread your question so that you don't give away any easy errors. Minus 143, because we know it's the information says that it's 143. There is there. Okay. So we're going to get is bring over the take away the 143, and what we get is 4x squared. The 20 plus the 16x gives you 36x, and the 80 minus 143 gives you minus 63 equals 0. Solve the equation to find the width of the path. Well, to solve this equation, what we can do is we can do the minus b formula if we want. So we can say that a equals 1, a equals 4, b equals 36, c equals minus 63. That's what you get when you match up this equation here with the minus b formula. And then what we get is minus b plus or minus the square root of b squared minus 4ac all over 2a. And what we should get now is we will get minus 36 plus or minus the square root of 36 squared minus 4 times 4 times minus 63 all over 2 times 4. Now we can put this in the calculator, and what we should get is just put this part into the calculator first. Okay, this is the important part. Okay, so we go square root of 36 squared minus 4 times 4 bracket minus 63 is 48. Okay, so it's 48. So what we're going to get here is minus 36 plus 48 plus or minus 48 minus 36 plus or minus 48 all over 8. Now that breaks up in two answers: minus 36 plus 48 over 8, or minus 36 minus 48 over 8. Now what you got to remember is it can't be a negative answer, so this one doesn't count, because minus 36 minus 48 is a negative number. It has to be a positive number. So what we do next is just put this directly into the calculator. Minus 12 plus 48 divided by 8, and we get 9 over 5, 4.5. Okay. Now minus 4.5 is not the right answer. You can see where I made the mistake here. I actually put in minus 12 when I actually should have put in minus 36. Okay. So what it is it's x equals 1.5, not 4.5, not 9, 4.5. It's 1.5. Okay. So x equals 1.5 is the answer. Okay. Tony does not answer the problem by solving the equation. Instead, he does it by trying out different values for x. Show some calculations that Tony might use to solve the problem. Well, what he might have done was, he doesn't solve the equation, so what he does is he has the equation here. Okay? And what he does is he might just pick values to use. So he might try x equals 1. Okay? And what he has to do is he has to figure out if this equation works. Okay, so he's going to pick a value to see if it will work. So it's going to be 4 times 1 squared plus 36 times 1 minus 63. We put that into the calculator. 4 bracket 1 squared plus 36 times 1 minus 63, and what we get there is minus 23. So we can see that that doesn't equal. Okay, so it doesn't work. That number doesn't work. So what you might try next is he might try x equals 2, because x equals 1 didn't work. So he's going to try x equals 2, and once again he replaces all the x's with 2's, and he sees what happens this time. Okay. For bracket 2 squared plus 36 multiplied by 2 63, and that's plus 25, okay? So 25 equals 0. So you can see that he's not able to balance the equation, which means he can't find the right answer, okay? So that's some calculations he might use to solve it. Now, which of the three methods do you think is the best? Give a reason for your answer. Well, I think Elaine's is the best. And the reason why I think Elaine's is best is it's the quickest way to get the equation. The equation for the area. And she solves it. She solved the equation. Which means she didn't spend too much time doing trial and error. Time doing trial and error. Okay. Next one, question 11. Okay. Part of the graph of the function y equals x squared plus ax plus b, where a, b is an element of z, is shown below. The points 2, 3 and 5 minus 4 are on the graph. Use the given points to form two equations in a and b. Okay. Well, what this means is that if y equals x squared plus ax plus b, remember y is the output, x is the input, so this is x and y, this one here is x and y. Now these values of x and y should work in this equation. So what we do is we put it 3 equals 2 squared plus a times 2 plus b. And what we get is 3 equals 4 plus 2a plus b. Bring the 4 over the other side and we get minus 4. So what we will get is 2a plus b equals minus 1. The next one, x equals minus 5 and y equals minus 4. So this time we're going to get minus 4 equals minus 5 squared plus a times 5, or minus 5 plus b. And what we get is minus 4 equals 25 minus 5a plus b. Bring the 25 over the other side and it'll become minus 25. So we'll get is minus 5a plus b equals minus 29. So that is the two equations there, equation A and equation B. Next one, solve your equations to find the value of A and the value of B. Well, the value of A is going to be 2a plus b equals minus 1, and then we're going to multiply this one by minus 1, so we get plus 5a minus b equals 29. So this way we can get rid of the b's straight away, and then when we add it down we get 7a plus 0b equals 28. A therefore equals 4. Now when a equals 4, we now got to find out what b is. So 2 times a plus b equals minus 1, taking equation A. 2 times a is 8. 8 plus b equals minus 1. Bring over the 8, it becomes a minus 8. b therefore equals minus 9. Okay, now what this means is the equation of the line, or the curve, is y equals x squared plus 4x. It's plus 4 minus 9. So this is it here. Okay. Okay. So this here is the equation of the line. So we're just going to bring this down here. Okay. So now that we have this down here, we're going to do what we'd normally do to draw the graph. Okay. Write down the coordinates of where the point of the curve crosses the y-axis. Okay. Well, it crosses the y-axis when x equals 0. So when x equals 0, we're going to get y equals 0 squared plus 4 times 0 minus 9. Y therefore is minus 9. 0 minus 9. Remember this line here, x always equals 0 for any point on this line. Okay? Now, find the points where the curve crosses the x-axis. Now when it crosses the x-axis, on the x-axis, which is represented by these blue dots here, y always equals 0. So what you do is you get your equation and replace y with 0. So now we get x squared plus 4x minus 9 equals 0. This here is a minus b formula. So what we're going to get is going to compare to ax squared plus bx plus c. Now the reason I knew it was a minus b formula is because it says correct to one place of decimals. It means that it's more likely going to be it has to be a minus b formula. Okay, so we're going to say that a equals 1 because whatever number comes in front of the x squared, b equals 4, and c equals minus 9. So we're once again going to do the minus b formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a. And this is to find out what x is, okay? So what we're going to do next is we're going to get x equals minus 4 plus or minus, because if b is 4, minus b has to be minus 4, into the square root of b squared, which is 2 squared, minus 4 times 1 times minus 9, all over 2 times 1. Okay, and what we get here is going to be minus 4 plus or minus the square root of. Now we can put this into the calculator right away. It's going to be square root of 4 squared minus 4 bracket 1 bracket minus 9 2 root 13. Okay, so it's going to be 2 root 13, and that's all going to be over 2. Now this means there are two answers exactly like last time. X is equal to minus 4 plus 2 root 13 over 2, or minus 4 minus 2 root 13 over 2. Now once again, this time x is a negative number because it's left of the y-axis, and it's a positive number because it's to the right of the y-axis. So we're going to get two numbers and both answers count. Okay? So I'm just going to put them both into the calculator. Now before we could do this, we could also divide these by 2. Okay? And we might get minus 2 plus root 13 and minus 2 minus root 13. But why risk not knowing it? You can always use it in the calculator. So you can always say minus 4 plus 2 root 13. Sorry, 1 second. Minus 4 plus 2 root 13 all over 2. And we see that's minus 2 plus root 13. Change it to one decimal place. 605. It's going to be 1.6. Okay, so 1.6 for x. And then the other one, which is a minus 2 root 13. This one here. So that's the third form. We want it in decimal form, which is minus 5.6. So there's our two answers there. Okay. So this was from question 6 up to question 11.